So thank you, Mr. Chairman. As you said, we will talk about light propagation in translucent or transparent material on a diffusing background. This is the subject of my internship. For the first part of my internship, we will talk about teeth, exactly about the dental materials, which are the translucent materials. The objective is we want to predict the right color of one teeth, whatever the thickness is, and this can be achieved using some optical models. So the study is based on the optical characterization of these translucent materials. That means that we will have to find some parameters that will allow us to predict the sample's appearance, which is really difficult due to the translucency. The gold standard method used in dentistry is the Kubel-Kamunck model, the application of Kubel-Kamunck model on a drawn-down card, and the sample is in optical contact with the card. And this to fulfill the condition of the material must be highly scattering. The measurements, this application needs a set of measurements, and they are done with the spectrophotometer. And this device illuminates our sample with perfect diffusive lights and measure the reflectance on a specific angle. At the end, we want to verify the prediction accuracy of this model using the colorimetric distances called CIE delta E 2000. So the model works on this way. We have our absorption coefficient K and the scattering coefficient S for a sample with a thickness H. And we have also the reflectance of the background, the black background and the white background. And from this parameter, we can predict the reflectance of the sample on the black and the white background. But in our case, we don't have this parameter directly, so we have to apply the inverse Kubel-Kamunck model. It means we will have to measure and find this parameter, then we make our predictions. So to sum up, we will measure the reflectances on a white and black backgrounds, and then by applying the inverse Kubel-Kamunck model, we will have our optical parameters K and S, and then we will predict the reflectances for one material, but for different thicknesses by applying the direct Kubel-Kamunck. So here we have an example of our materials to illustrate what we said. The material is called A2, and this figure shows the evolution of a reflectance factor in terms of wavelength. This is for the white background, we call it RW, and this is on the black background, we call it RK. For the black background, we see that we have more reflectance for more thickness, and for the white background, it's the inverse. Since we have our reflectances, we can compute our parameter K and S. The coefficients should be constant. As we see, for K, it's constant beyond the blue domain. In the blue domain, it's not the case. For S, as we see, it strongly depends on the thickness, and it's not the same. So we can say that our material is not diffusive enough. Luckily, we have this coefficient called A, and this coefficient will give, it depends on K and S, and give us important information about the validity of the model. And, as we see, the figure, the curves, so the curves fits almost for all the thicknesses. And now we can move to our prediction, reflectance predictions. The results are pretty good, as we see here, and since as long as we have good calibrated system, our system was calibrated using by extracting the parameter K and S from the thickness 1.2 millimeters. This is why here we have a good, perfect superposed curves. And to evaluate these differences here, we will use the colorimetric distances. And these distances will give us the difference between the prediction and the measurement that we did, taking into account the AI perception. And they also give us an important information about the validity of the model. Here we see on the white background, we have small differences, and this is for the black background, and it's a little high. So to conclude, you can say that the Kubernetes model gives good prediction accuracies on the white background, but it's not the case for the black background, and that was approved with 10 different other materials. But now we are asking ourselves, what if we will use translucent background? What we will have and what we will get as a result? For a second part of my internship, we are working on light propagation in transparent materials. And we want to study the amount of light that travels from a point A to a point B. And after that, we come with another point, intermediate point, to disturb the flux that moves from A to B. And what we want to have a change in light color in point B and also in intensity. That's it. Thank you for your attention.